Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics, SNS College of Technology. So in this video, I am going to explain about design thinking for single crystal applications. So a 5-step journey. Okay, so a 5-step journey, right? So design thinking involves on the 5 steps that called empathy, define, ideate, prototype, and testing. We have 5 steps, right? So how the design thinking applied for the single crystal application. So in this video, I am going to explain about the design thinking how applied for the single crystal applications. So unlocking innovation through systematic understanding of the single crystal technologies, right? So here our empathy is understanding the user needs in single crystal technology. Okay, so single crystals power critical devices from quartz watches to semiconductor and laser optics. Okay, user demand precision, reliability and efficiency in challenges, crystal defects, growth cost and application specific performance. So these are all the empathy. So empathy is the understanding the user needs in the single crystal technologies. So here the single crystal technologies are quartz watches or semiconductor watches too. So it has many applications. So from quartz watches to semiconductor and laser optics. Okay. So using users demand precision. So we have to apply the empathy here. So empathizing with engineers and scientists reveals the challenges, crystal defect, growth cost and application specific performance. These are all the empathy. So next step is define. The fine pointing the core problems. So we have in empathy step we find the many core problems. So in define, so fine pointing the core problems. The first one is crystal growth efficiency. So how to grow large and defect free single crystals efficiently and cost effectively. This is the first defining point. Second one is performance optimization. So how to tailor crystal orientation and shape for optimal device performance. Okay, so first one is crystal growth efficiency. So how to grow the large and defect free single crystals. Second one is performance optimization. So how to tailor the crystal orientation and shape for the optimal device performance, right? So next one is the quality assurance. Okay, so how to visualize and characterize the crystals to ensure the quality and functionality. These are all the defined sections. So next section is the ideate. So ideate section is nothing but exploring the innovative solutions, right? So first one is advanced growth materials, simulations tools and custom shaping. Okay, so in define section we see that so how to grow launch a single crystal and defect free single crystal. Okay, so we have used advanced growth methods. Okay, so we have many advanced methods, so like Chokralski method, hydrothermal method and chemical vapor deposition technology. So in recent days we have the method SR method. Okay, so we have many methods. So these methods, these are the advanced growth methods. So using these methods, we have to grow a large sized single crystal with large size single crystal with low defect with zero defects, right? So next one is simulation tools. So single crystal softwares to visualize the diffraction patterns and crystal morphology. So we used some single crystal software to visualize the morphological crystal morphology and diffraction patterns which will be visualized by the single crystal software. Okay, these are the simulation tools. Okay, so next one is custom shaping. So crystal orientation control to enhance the piezoelectric and optical properties. So depending on the orientation only, the crystal properties will be enhanced. Okay, so depending on orientation, crystal orientation, we easily control the enhance piezoelectric and optical properties. These are all the exploring innovative solutions of ideate part. Okay. So next step is prototype. So prototype is nothing but bringing ideas to the life, right? So first one is design development, next virtual prototyping and test crystal application fabrications, right? So first one is design development. Okay, so creating precise temperature control and insulation system for the optimal crystal growth condition. Okay, so we are using advanced crystal growth techniques, right? So so that we have to create the precise temperature control, so and the insulation system for the optimal crystal growth conditions, right? So this is the furnace design development. Okay, so we achieve the perfect crystal growth. We have to use this prototype. Okay, so these are only some ideas. Okay, so furnace design development. Okay, so furnace design development, we have to create the precise temperature control. Okay, so next one is virtual prototyping, using diffraction simulation to predict crystal behavior. So before physical growth. Okay, so what's the behavior of the crystal in before the physical growth? Okay, which will be monitored by the virtual prototyping. Right. So next one is test crystal fabrication. So creating crystal with varied cuts and shape to evaluate the performance and in a sensors and semiconductor devices. Okay, so these are all the prototype part, right? Next one is testing or validating performance. So refining the designs. Okay, so structural analysis. Okay, single crystals, X-ray diffraction to analyze the atomic structure and detecting defects. Okay, so testing part will the X-ray diffraction will be taken for that crystals. So from this X-ray diffraction we get the atomic structure and defect of the crystals, right? So frequency testing, measuring the vibrational frequency in quartz crystal for timekeeping accuracy. Then properties validation. Okay, or testing optical clarity and electrical property for the application readiness. Okay, these are all the testing part of our system. Okay, so next one is our case study. So quartz crystal in timekeeping and sensors. This is the case study. Now the piezoelectric advantages. The quartz piezoelectric effect enables precise oscillations in watches and sensors, and crystal cut angle and size directly influence the resonant frequency and device accuracy. So design thinking lead to innovation in crystal growth and shaping, improving the device reliability. Okay, so normally the standard quartz crystal frequency for the digital timekeeping will be 32.768 kilohertz frequency. So after that the part of per million, after that the design thinking applied to the material, so it will be the plus or minus 15 ppm accuracy, the part per million precision in modern quartz oscillators. So visualizing the crystal growth and structure, so 3D simulation, interactive projections and rapid prototyping. So these are all the visualizing crystal growth and structure in this case study. So impact of this case study is, so impact of transferring the industries with single crystal innovations. So single crystals are used in semiconductors and optics and quantum technologies. Okay, these are all the transforming industries with single crystal innovations. So design thinking unlocks the future. So in future, design thinking unlocks the future. So we have 5 steps called empathy, define, ideate, prototype and testing. So empathy is nothing but understanding real world challenges. Define, focusing innovations on previous problems. Ideate, generating the breakthrough solutions. Prototype is nothing but accelerating the development, and the test is ensuring the reliability in the performance. So these are all the design thinking based case study. Thank you all.